new world. The Red Planet has a story, and it begins now.
Mars Saga presents a journey beyond the red dust, beyond the silent plains, and beyond the cold winds that shape the surface of the planet. This episode explores the hidden world beneath Mars, a world made of stone, ice, pressure, and time. Long before spacecraft touched its soil, Mars was already building its story layer by layer, deep under its surface. What appears today as a dry and quiet planet holds within it the memory of powerful forces that once shaped its interior. Mars formed more than 4 billion years ago from the same cloud of dust and gas that created Earth. In its earliest age, the planet was hot, active, and restless. Volcanoes released massive flows of lava, underground chambers filled with molten rock, and the crust slowly thickened as the planet cooled. These early processes built the foundation of everything that exists on Mars today, including its mountains, valleys, and the vast underground structures hidden far below the surface. Beneath the red soil lies a thick crust made of basaltic rock, formed by ancient volcanic eruptions. Below this crust rests the mantle, a massive layer of dense minerals that once carried heat upward from the planet's core. At the center is a metallic core rich in iron, sulfur, and nickel. Although Mars is smaller than Earth, its interior tells a story just as complex, shaped by pressure, chemical reactions, and the slow movement of energy over billions of years. For a long time, scientists believed Mars was completely geologically dead. The surface appeared frozen in time, untouched by plate tectonics, rivers, or major changes. But modern missions began to challenge that idea. Instruments carried by orbiters and landers revealed faint vibrations within the crust, subtle movements that proved Mars still shifts and adjusts deep below the ground. These slow tremors are evidence that the planet's interior is not entirely silent. One of the most important discoveries came from NASA's InSight lander, which studied Marsquakes. These vibrations traveled through layers of rock, allowing scientists to measure the thickness of the crust, the composition of the mantle, and the size of the core. The data revealed that Mars has a surprisingly large liquid core and a mantle that still holds traces of warmth from the planet's violent youth. Heat inside Mars plays a critical role in shaping its underground environment. Long ago, this heat drove volcanic activity that covered wide regions in solidified lava. Some volcanoes on Mars grew taller than any mountain on Earth, building structures so massive they altered the planet's gravity field. Beneath these volcanoes, magma chambers formed and collapsed, leaving behind vast empty spaces inside the crust. These empty spaces became pathways for fluids, gases, and minerals. Water, once abundant on the surface, seeped downward through cracks and fractures. Over time, it collected in underground layers, forming reservoirs trapped beneath rock and ice. Even after surface rivers disappeared, water may have remained below, protected from solar radiation and extreme temperatures. Radar instruments aboard orbiting spacecraft detected unusual reflections beneath the polarized taps. These signals suggest the presence of liquid or semi-liquid water mixed with salts, forming dense underground lakes. These reservoirs are buried under kilometers of frozen ice, sealed away from the harsh surface environment. If confirmed, these hidden lakes would represent one of the most stable environments on Mars. Temperatures underground remain more constant, shielded from daily extremes. Radiation is weaker, blocked by layers of rock and ice. Chemical reactions between water and minerals could continue slowly, shaping the underground landscape in complete darkness. The rocks themselves hold valuable information. Many underground minerals form only when water is present. Clay, sulfate crystals, and carbonate deposits have been detected across Mars. These chemical records show that water once moved through the crust, dissolving elements and leaving new compounds behind. As water flows through rock, it changes both itself and the stone it touches. Minerals dissolve, new crystals grow, and tiny channels form within the rock structure. Over millions of years, this process reshapes entire underground regions. Some areas become hardened and sealed, others weakened and hollowed out. These slow chemical transformations may still be happening today, far below the surface. Even in small amounts, liquid water mixed with salts can remain stable at low temperatures. Such briny solutions could exist deep underground, moving slowly through microscopic cracks. Inside these dark environments, organic molecules could survive for long periods. Carbon-based compounds have already been detected in Martian soil and rock samples. Protected underground, these molecules would be shielded from ultraviolet radiation that destroys complex chemistry on the surface. The underground world of Mars is not empty stone. It is layered, structured, and shaped by invisible forces. Pressure increases with depth, compressing minerals into new forms. Heat rises gradually, changing the physical properties of rock. Chemical reactions occur silently, creating new materials never seen at the surface. Some regions of the crust are heavily magnetized, preserving traces of Mars's ancient magnetic field. These magnetic minerals record a time when the planet had a global shield protecting it from solar winds. When this field disappeared, the atmosphere began to thin, and surface water slowly vanished into space or retreated underground. Deep beneath the plains, ancient river systems may still exist as fossilized channels filled with sediment and minerals. These buried channels mark the paths where water once carved through rock, transporting material from highlands to basins. Over time, they were sealed under layers of volcanic ash and dust. The presence of these buried channels suggests that Mars had an active underground water cycle similar to Earth's aquifers. Rain and snow may have fed groundwater systems that extended across entire regions. Even when the climate changed, parts of these systems could have remained intact. Modern exploration cannot yet drill deep enough to reach these hidden layers. Current rovers study only the surface and shallow subsurface. However, their discoveries guide scientists toward promising locations for future missions. Sample return missions aim to bring pieces of Mars back to Earth for detailed laboratory analysis. These samples may contain microscopic structures formed underground, trapped inside minerals for billions of years. Even without biological origin, such structures reveal the conditions that once existed within the planet. Future landers may carry advanced drills capable of reaching deeper into the crust. These tools could extract ice, minerals, and possibly liquid brines. By studying these materials directly, scientists will learn how Mars stores water and how its interior continues to evolve. Understanding Mars's underground world is also essential for human exploration. Future explorers will need water for drinking, oxygen production, and fuel. Subsurface ice and reservoirs could become vital resources for long-term missions. Underground habitats could offer protection from radiation, temperature extremes, and dust storms. Natural caves formed by ancient lava flows, known as lava tubes, have already been identified from orbit. These tunnels stretch for kilometers beneath the surface, wide enough to shelter entire habitats. Inside such caves, temperatures remain relatively stable. Walls block harmful radiation, and thick rock layers provide insulation. These environments could become the first safe shelters for human explorers. Beyond practical use, the underground world of Mars represents the deepest archive of its history. Each layer records a different chapter, written not in ink, but in stone. Volcanic eruptions, floods, climate shifts, and atmospheric loss are all preserved beneath the surface. Mars today appears quiet, but beneath that stillness lies a complex structure shaped by ancient fire and water. The planet continues to cool slowly, releasing heat at a pace too gentle to notice from above. Every tremor detected by instruments is a reminder that Mars is not a frozen statue. It is a world still settling into its final form, adjusting to the slow rhythm of time. The deeper scientists look, the more Mars reveals that its story is not limited to what can be seen from orbit or from a rover's camera. Its true history lies buried under kilometers of stone, waiting to be uncovered. Future missions will continue to peel back these layers, one sample at a time. With each discovery, the understanding of Mars grows clearer, transforming it from a distant red dot into a complex planetary system shaped by the same physical laws that govern Earth. Mars remains silent on the surface, but its underground world speaks through data, minerals, and subtle vibrations. It tells of heat that once surged, of water that once flowed, and of chemistry that continues in darkness. This hidden realm does not promise life, but it preserves the conditions that make life possible. It shows that Mars was once dynamic, layered, and evolving, and that its story is far from finished. From frozen plains to molten depths, Mars carries the memory of a planet that once stood closer to Earth in nature than it does today. Mars Saga will continue to explore these chapters, written not in words, but in stone.